Let me get my notes up so I know what I'm talking about. Organic. I'm just trying to find my list. Okay. Cool. So let me make that bigger. Okay. So we have an activity. Can we listen up and be ready to get some notes done? Ready? Okay. So with this first activity, we were thinking about example and non-example. I have my first example for you, which was bute and 1-all. And that looks like CH3, CH2, CH2, CH2OH. Yep. What function group is that one? Alcohol. All right. Then I had a list of organic molecules, and I asked you, is this an example or non-example? So basically, does it belong with butane 1-all or does it not belong with butane 1-all? The first one, so I'll keep these guys as my example list. And I'll have another list going here as my non-example. All right, so first molecule that you guys have was butane 2-all. Is butane 2-all an example or a non-example? It is an example. Yeah. So CH3, CH2, CH, OH, and then CH3. All right, the next one, oh, sorry, let me focus it back again. All right, the next one that I have is butane 1-amine. Did you guys think that was an example or a non-example? Non-example, good. All right, next one that I had was butanone. Example or non-example? Not an example. What function group is that? Ketone. Thank you, Klein. Taking credit for Brooklyn. All right, 2-methyl propane 1-all. Is that an example or non-example? That one is an example as well. Sorry, prop and 1-all. Thank you. All right, so methyl's on carbon number 2. Could the methyl be on carbon number 1? No, because then that would make it a butane. Methyl, propane, 1-all. All right, next example, 2-methyl, 2-propane, 2-all. Example? So CH3, CH, actually, no CH. That should be OH, CH3, CH3. All right. And then I had butanal. Example or non-example? I hear example from this side. I hear non-example from that side. It is a non-example. That's okay. You're playing like vocab detective. You weren't going to necessarily be right. I hadn't taught you guys this stuff. What type of function group is that? What type of function group? It's an AL ending, so it's an aldehyde. All right. Last one, 2-methylpropane. Non? What do we hear on the other side of the class? All right. This one here is not an example. All right. So before I tell you guys the answers, I'm just going to zoom up here. What kind of thought process did you guys have when you grouped the examples together? They all have alcohol, good. I should have probably stuck in another alcohol that was shorter. I'll put that in. If I had prop and 1-all, would prop and 1-all be an example or a non-example? Prop and 1-all. Example or non-example? It's an alcohol. It is a non-example. I'll put that one on there. It's a good example. Propan 1-all. No, you're confused. That's okay. All right. So what we are thinking about is with these examples, yes, all of them have alcohols. What do they also all have? No double bonds. How many carbons are there? 4 in all these examples. So even though this is 3, there's a methyl group, so you have a total of 4 carbons. So if I went through and I was doing their molecular formula and I was condensing it down, I would have 1, 2, 3, 4. Actually, I might write that in different colors so you guys can see what I'm talking about. There's C4H. How many H's do I have? 2, 4, 6, and then another 2 more. 8. Sorry, not 8. 10. And then how many oxygens? 1. And this guy? 1, 2, 3, 4 again. Hydrogens? 10 again. Oxygens? 1. 2-methylpropan 2-all. 1, 2, 3, 4. Hydrogens. 3, 3, 6, 7, 8, 9, 10. 1 oxygen. Last one here. 1, 2, 3, 4. 3, 3, and 3, 9. Another 1, 10. And then 1 oxygen. So what do they all have? Same molecular formula. If we look at these guys over here, this one's not the same because it has 1 less hydrogen. So if I was to write the formula, it would actually be C4H8O. 3 and 3, 6, another 2, 8. So that one's out. Same with this guy here. This one here, missing the alcohol. This one here, too few carbons. C3H 6, 7, 8. Hold on. 3, 4, 5, 6, 7, 8. Yeah, 8. Okay. So what we are looking at here is something called structural isomers. They have the same molecular formula, but different bonding arrangements. So that's what my structural isomers are. Same molecular formula, different bonding. So we see here that we have different branches. We have the alcohol in different locations. That's what's causing that. So if they don't have the same molecular formula, they are not isomers of each other. And there's one more thing I wanted to show you before we moved on. Are we good? Okay. The next thing I want to show you, just so that way we can start getting more vocabulary in us, is this idea of primary, secondary, and tertiary when we are classifying our isomers. So what we are looking at is where is the functional group attached and how many carbons are attached to that carbon. So when I look at this first molecule here, I see that alcohol is attached at the end. This is the carbon that it's attached to. How many carbons are attached to that carbon? Just the one over there. So this is an example of a primary alcohol. This one here, that's where my alcohol is. Check the carbon that it's attached to. How many carbons are attached to that one? 2. So it's a secondary. This one here, there's my alcohol. That's my carbon. How many carbons is that carbon directly attached to? Just the one. So that's my primary. And then this one here, there's my OH. There's my alcohol. Oh, sorry, there's my carbon. 1, 2, 3. So that's an example of a tertiary. Just trying to get you guys used to the naming. It's for isomers that have things like alcohols, amines, and halogens. They often ask this as a classification key. Yeah, so it helps you classify. It helps as a hint to what your structure would be. Okay? Moving on. Questions, concerns, comments? Nope? All right, I'm going to pause the recording here. We're going to take a break with a Kahoot just to make sure you guys understand the basics before I jump into something more complicated. Okay. So, what I want you guys to also be mindful of when we are talking about isomers is that it is possible to have different types of functional groups, and they are structural isomers of each other. Let me give you an example of one. I'm just trying to think of the formula off the top of my head, which isn't working too well. Let's see. So let's say we have something that is the molecular formula of C3H. I got to figure out how many numbers we need. There's an N and there's an O. Let me just write down the molecule real quick so that way I can count the hydrogens. What's that? 2, 4. 4 plus 3 is 7. All right. Yeah, that's what I want. Okay. So this is my molecular formula. What I'm trying to do is I'm trying to think about organic molecules that would have that molecular formula. The first one, and the one that I'm designing this problem off of, is an amine. Sorry, an amide. So an amide is CH3, CH2, C double bond O, NH2. So that's my original one that I'm thinking of. And this one is an amide. Are we okay with that so far? Now, when I'm thinking about this example and I'm trying to think about what other potential structural isomers I might have, I want to move around different functional groups and move around my carbon structure to see if I can get another format. Are we okay with that so far? First off, can I move the whole amide group to another section? If I move it to carbon number 1, is that a new molecule? No. So it's still going to be propan amide. Okay? So that's my first sort of thought process. I could move the carbons around. Actually, I won't talk about that because I think it's going to confuse you. No, actually, I should probably talk about it because you need it for a spec. All right. I could move some of the carbons around. What I could do is I could move this carbon onto this side of the amide, and it's still an amide. So I have CH3, C double bond O, N, and now it's going to be N1 because I'm going to lose one of those hydrogens so it can make a bond with the carbon over there. Looks like that. That is still an amide. Are we okay? So all I did was I took this CH3 and I moved it over here. Okay? So that's another isomer that's still an amide. So if I was to go, I'm going to name it. Don't worry about the naming process. I just want to show you that naming is really important because that tells me that I have naming is a really good way to tell if you have something new. Don't worry about naming this one. I just wanted to show you guys another amide. I just wanted to show you that was possible to do. All right, some other things I can do is I can move around the functional groups separately. So I can move the carbonyl and I can move the amide, sorry, the amine. So for example, I could have CH3, C. So that is another isomer. Do you see how I've moved in this case? Huh? Do you see how I moved this OH down one carbon? So you see how I have this carbonyl, the double bonded O? I've moved it from being on the first carbon to being on the second carbon. Huh? Why did I remove the hydrogen here? So the hydrogen here, one went to this one over there. Actually, yeah, one over there. So I should still have the same number. 1, 2, 3, 4. Yeah, 2, 4, and then 3. So 7 hydrogens. 1 nitrogen, 1 oxygen. Now, is this still an amide? No. Because the double bonded oxygen and the NH2 are not on the same carbon. So this is now a ketone and an amine. Amine. I could also move this double bonded carbon down another one. We could have CH, CH2, CH2NH2. That's another isomer. That one now is an aldehyde and amine. That's okay. I'll give you guys some time to practice. All I'm trying to do is I'm just trying to move around the atoms in my molecule and making new formulas. They all still have at the core 3 hydrogens, 3 carbons, 7 hydrogens, 1 oxygen, and 1 nitrogen. All right. I could also move the nitrogen around. Let's say I want to keep the double bonded oxygen on the first carbon. I could have the NH2 on the second carbon and have that as well. That's another option. That one would be an aldehyde, an amide or amine. It's only an amide if the carbon, the carbonyl, the double bonded oxygen, and the nitrogen are attached to the same carbon. So it's only an amide if these two things are attached to the same carbon. If it's not attached to the same carbon, they have then moved. Yeah, that's how I figured it out. Yeah, I can pull it down. All right, I want to show you guys one more one just because, like, just to give you a list of ideas of what is possible. All right, what I could also have, and this would be a nasty thing for me to give you, is an alkene, which is a double bond, something that is now an alcohol, and something that is now an amine. Actually, what is that? No, I shouldn't have anything there. 1, 2, 3, 4. And that would be CH2. 2, 4, 6, 7. Yeah. And if you check the number, sorry? CH2, double bond, C, I'm crossing that one out, OH, CH2, NH3, or sorry, NH2. So I see the double bonded there, that's an alkene. I see I have an OH, that's an alcohol. And I see I have an NH2, which is my amine. But again, it still fits the parameters of the original formula. When I go through and count, there's still 1, 2, 3 carbons. When I go through and count the hydrogens, I still have 2, 4, 6, 7. And then I still have 1 oxygen and I have 1 nitrogen. So I just want to show you guys that with the structural isomers, especially once they start chucking in functional groups, there's lots of different options in how you arrange things. All right, I might leave it there for now. C, what is it, 3H7ON isomers. We have 1, 2, 3, 4, 5, 6, 7 options on that. As an amide, yeah. So there's 7 options. I have found 1, 2, 3, 4, 5, 6. So there's one more that I could have done. All right. Are we okay with that? A little bit. Okay. So I will let you guys have some time to practice.